Hello, good morning, respected audience. My name is Salman Parvez. I am Associate Professor of Mechanical. I am going to present the topic reviewing post-processing techniques to enhance mechanical properties of parts fabricated using wire arc additive manufacturing technique. And the agenda of the presentation is as shown. As far as the motivation is concerned about this work, it is because wire arc additive manufacturing system is gaining popularity in the industrial sector because it's not limited to produce the prototype only. It also being used to produce valuable and cost-effective large near-net parts. There is a need in industry to develop more effective methods to generate less surface roughness and improve the material microstructure. Generally, surface roughness and residual stresses, they are termed as the major problems in the 3D printed parts using WAAM technology. When it comes to the post-processing methods, rolling operation has been observed as a viable option to be used as post-processing in the WAAM technology. The advantages are linked with the betterment in the internal grain features, the surface waviness improve the material microstructure, a significant reduction in the internal residual stresses. And when the rolling operation is considered with the other post-processing operations such as forging and vibration assisted post-processing methods, rolling operation outclass the other ones. First of all, what is meant by wire arc additive manufacturing? In wire arc additive manufacturing, a layer by layer welding operation is carried out through a welding torch by using a consumable wire in 3D space. WAAM technology dramatically contributes in reducing the production time, cost, and the wastage of a material. A post-processing operation is a way of improving the surface finish and the mechanical properties of material by means of different approaches. In case of WAAM process, rolling, forging, and vibration-assisted techniques are used as a post-processing methods. These methods allow reduction in internal residual stresses, porosity, and surface roughness. However, the yield and ultimate strength is improved. In this current study, rolling process as a post-processing operation has been focused for the WAAM produced parts. Rolling process parameters are very complex in nature, so both experimental and numerical studies were included in this review paper. The major focus of this work is on the rolling process. However, rolling process was also compared with the forging operation as well. In this work, two different variations of rolling process as a post-processing method were investigated. The first one is in-process rolling operation and the second one is rolling process after the WAAM operation. Both were investigated. At the end, the different options or different ways were also investigated at how to reduce the internal residual stresses and how the mechanical properties of the fabricated part can be improved. The efficiency of rolling process depends on the rolling parameters. In the rolling operation, mounting of the roller on the welding setup is also very important. Two different rollers have been used to apply a specified pressure around the weld point. Single roller diameter fixed behind the welding tool allow pressing the weld point in the molten soft condition and was found more efficient than the first method. The single roller has higher response and effect with increasing the roller pressing load than the double attached roller system. The residual stress is a very important and critical factor that is leading to cause an unexpected failure that is out of the plane distortion on the produced parts in the WAAM process. A study showed a positive impact of using different roller geometries on reducing the residual strain. The slotted roller is able to reduce the strain about 6 times in case of applying a load capacity of 50 Newton comparing with the status of no load. In order to improve the overall strength, rolling process is mandatory. Large roller diameter improves the recrystallization process and extends the area that enhances the grain size uniformly In addition, by increasing the rolling applied load, the average grain size reduces and provides higher strength. Poor surface finish and waviness are considered as major problems in the WAAM printed parts. The waviness of the surface supports the increase in internal stresses and has a serious effect on the fatigue life of the produced parts. As shown in the picture, the increasing the rolling load decreased the surface waviness. It showed a 0.18 mm surface waviness without applying any load, but it decreased with increasing the load, and it reached the value of 0.08 mm after applying the load of 16 kilonewton. Forging is another post-processing option to improve the deposited material. Avoiding replication time is one of the features of this deformation method. For example, as shown in this schematic diagram, uh, there is an actuator connected with the hammer, and there is a vibrating actuator. So there is a vibrating hammer just behind the torch, and it can provide the plastic deformation to the material as required. Several attempts have been made to numerically model the WAAM process and the rolling operation. For example, in this current slide, you can see that rolling of WAAM sample was simulated using a finite element method software through Abacus. The major conclusions out of this work were: the roller profile radius has an insignificant effect on the depth of the residual stress, and as the rolling load increases, the depth of the compressive residual stress increases as well. The major conclusions out of this study are as below. The rolling post-processing operation was found more effective than the forging operation in terms of reducing the residual stresses. However, forging is better in terms of time saving. The optimal distance between the torch and the roller was found to be 10 centimeter. By increasing the rolling force, the surface waviness and surface roughness also decreased. Larger roller radius will improve the ability to release residual stresses from the deposited sample. As the distance between the roller contact point and the torch welding edge increased, the grain size increased as well. Thank you for your attention.